Ennemcien. Here's a problem. For instantaneous center. I shall read the problem. A rod AB of length 2 meter is supported by smooth horizontal and vertical planes, and it begins to slide without detaching from the planes. Calculate the velocity of the end A, capital A, and the middle point C when the end B slides with velocity 4 meters per second and the rod makes 60 degrees with the vertical plane. See the problem. This figure is given along with the question. This is vertical wall, horizontal surface. Both surfaces are smooth enough so that the rod AB slides down. So the end A will move downward, B will move horizontally in this direction, and it is given that the velocity of B is 4 meters per second. At the moment the rod makes angle 60 degrees with the vertical surface. Length of the rod is given to be 2 meters. Here the question is, what is the velocity of A at this particular instant and velocity of the midpoint of the rod at this particular instant? Our first duty is to locate the instantaneous center. You can use the standard procedure I discussed in the last posting. Here there are two velocity vectors. One is VA, velocity of this apparent VA, vertically down. So foot of the velocity vector is at A. This is another velocity vector VB, foot is at B. What is the procedure? Just you draw two perpendiculars, one from A, the other from B. These two perpendiculars meet at I. So I is the instantaneous center of zero velocity in this problem. Next you draw, we have to find out the velocity of the center of the rod C. So just you draw. Now as far as this particular instant is concerned, the entire rod is in rotation. Every particle in the rod is in circular motion with I as the center, but radius may be different. You draw this line CI. So C is in circular motion about this point with CI as the radius. A is in circular motion with I as a center and AI as a radius. B is in circular motion like this for at this particular instant only. B is in circular motion with I as center and radius BI. So first you solve BI, AI, CI. Say BI, you take this right angled triangle. BI, this is BI. So you can solve BI using this right angled triangle. AB, this is a right angled triangle. In this case, this is a right angled triangle. So just to take cos 60. Cos 60 is BI adjacent side by hypotenuse. So BI by AB. Therefore, BI equals AB cos 60. AB is 2 meters, 2 into cos 60. Cos 60 is 1 by 2. So BI equals 2 into 1 by 2 or 1 meter. Similarly, AI is AB sine 60. That is 2 into root 3 by 2 or root 3. Now we know we are given value of VB. This is in circular motion. B is in circular motion about this point as its center. So V equals R omega. The basic formula is pure rotation. V equals linear velocity. V equals R omega. Here R is BI. And V is VB. VB equals R or BI into omega, from which we can find out omega, angular velocity of this point. Omega equals VB by BI. That is, VB is given to be 4 meter per second, by BI is 1. So 4 radian per second. This is omega. After finding the omega, we can find out VA, velocity of this point. VA equals R omega. R is AI into omega. We have got omega. So VA equals AI into omega. That is AI is root 3 into omega is 4. We have got it as 4. So VA equals 4 root 3 meter per second. One answer is okay. Next you have to find out velocity of the midpoint C. For that we have to find out the radius. It's the instantaneous radius. Radius at this particular instant, that is CI. We have to find out CI. For this, just to apply cosine rule in this triangle. CI equals BZ root, CI equals square root of BZ square plus BI square minus 2BC into BI into cos 60. That is square root of CI equals square root of 1 square plus 1 square minus 2 into 1 into 1 into cos 60. The final answer will be 1 meter. Then you can find out VC. VC equals CI into omega, because as far as motion of the point C is concerned, CI is the radius, because I is the instantaneous center of rotation. So V equals R omega or VC equals CI into omega, from which CI is 1 and omega is 4. So 1 into 4 or 4 meter per second. Quite simple. Thank you.